All right, let's talk about the proof quiz number 1. So, here's what we're going to do. I'm here with my assistant, Grace. I'll be walking her through this stuff for those of you watching on YouTube right now. All right, so it tells us that triangle ABD is congruent to CBD, because that's what they're referring to here, that these are triangles, right? So ABD is the top triangle, and CBD is the bottom triangle. So they're the same triangle because they're congruent. We want to prove that DB, this part right here, bisects this angle, ADC. That's ADC. So we want to prove that the red part cuts this part, this angle, in half. So I'm going to write this in pink. We have not proven this, but this is what we want to prove. We want to prove that those two angles are the same, okay? So the way we do that is we do it with CCP, corresponding congruent parts. So we write since what they gave us, triangle ABD is congruent to triangle CBD, we know that angle ADB is congruent to angle CDB. And how do I know that? Because ADB is in the same order as CDB, first, third, middle, first, third, middle. So I know that by CCP. Ringing a bell? Grace? Wonderful. So, and the reason I wrote that, because all these parts are congruent, right? This angle is congruent to this angle. These angles right here. But I don't need that. What I need to prove is that this angle and this angle are congruent, right? So I wrote that, because I know I need to prove that, and then I wrote how I knew it, okay? Therefore, I write what they told me. DB bisects angle ADC by definition. End proof. Right? How do we know that DB is a bisector of ADC? Well, it's a line that cuts it into two equal pieces. I just proved they're equal, right? So that, by definition, that's a bisector, right? That's an angle bisector, which you should hopefully know today for our quiz that we're taking. This one, let's pass on it for now. Takes a while. Let's go on to number 3. All right, so we have a transversal that's cutting two parallel lines. That's what the symbol means here, parallel. And when a transversal cuts two parallel lines, we get 8 angles, and we get special properties. They want us to prove that 2 and 8 are congruent, so 2 and 8. So using our angle congruency theorems, we can say that 2 is congruent to 6, so let's write that. So since we write line L is parallel to line M, right? That's what they gave us in the drawing. Since they're parallel, otherwise this doesn't work, angle 2 is congruent to angle 6. And we know that because angle 2 and angle 6 are corresponding angles. So corresponding angles theorem, or CAT. Do you remember corresponding angles, Grace? Top right corner is congruent to the top right corner. And so now that we have those, we can say 6 and 8 are congruent. By what? Why are 6 and 8 congruent? Anybody know? How about you? Why are 6 and 8 congruent, Dylan?
Vertical angles.
Vertical angles theorem, thank you. That's the scissor theorem, Grace, where if you open up one side of the scissors, it'll be the same on the other. That's always true. So 5 and 7 are also congruent, just a little fun fact. And our last step, because we showed that 2 is 6, and we just showed that 6 is 8, now we need to show that 2 is 8, because that's what they want, right? We write what they want. 2 is congruent to 8 by the transitive property. And remember, the transitive property is the property that's like, I'm touching the table's touching the pen, therefore I'm touching the pen. So 2 is touching 6, 6 is touching 8, therefore by the transitive property, 2 is touching 8. And that's our proof. Does that make sense, Grace? You know what I'm saying here? Yeah? Okay. Now we want to prove 1 and 4 are supplementary. Well, if you look at 1 and 4, 1 and 4 are on a line, aren't they? 2 angles on a line. We call that a linear pair. Linear pair theorem says if they're a linear pair, they must add up to 180. And if they add up to 180, they're supplementary. So let me write all that out. Since angle 1 and angle 4 are a linear pair by definition. We know that angle 1 plus angle 4, the measures, equal 180 degrees by linear pair theorem. Linear pair theorem states that if they're a linear pair, which I just said they are, then they must add up to 180. So I wrote that. I know they add up to 180. How do I know it? Linear pair theorem. Therefore, angle 1 and angle 4 are supplementary. And how do we know that? Because by the definition of supplementary, right? Supplementary says they add up to 180. So by definition. How do you feel about that one? Yeah? Turn the page. Let's talk about this triangle. So ABD is congruent to CBD. So they tell us that this triangle over here is congruent to the triangle on the right. So prove that B is the midpoint of AC. So how do we know B is equally dividing these two, right? Because that's what midpoint means, right? So we need to prove those two little tick marks that I put there, right? How do we prove that those two are equal? Well, it's similar to the first problem. So we start out, since triangle ABD is congruent to triangle CBD, we know that AB, the line segment, is congruent to line segment CB. So I'm writing what I needed to prove. I needed to prove that AB and CB are congruent, right? That's what I wrote in my diagram, so I wrote that down here. How do I know that? Well, they gave me the triangles are congruent, so I can use CCP. AB and CB are in the same location. First and second, first and second. So by CCP. CCP stands for corresponding congruent parts. The parts are congruent if the triangles are congruent. Did they tell us the triangles are congruent? Yes, so the parts are. Which parts? The ones that line up. That's what CCP is, okay? So our last step is to write what they gave us, right? B is the midpoint of big segment AC by definition. Right? I proved that B is in the middle by saying these two parts are equal, right? So B is in the middle. So that means it's a midpoint. How do you feel about that, Grace? Yeah, not too bad? All right. Then we'll try for the big one. Number 2. So they tell us that triangles are congruent. So I bet we're going to use CCP, right? They tell us the triangles are congruent. Let's find those triangles. ABG is this triangle right here. BCH, that's this triangle right here. And HGB, the last triangle. They're all congruent. So find the measure of angle GBH by proof. Well, GBH is this angle right here. So we want to find that angle measure. So here's how I'm going to do it. I know this is 65 and that's 35. So I start with what they gave us. Since triangle ABG is congruent to triangle BCH is congruent to triangle HGB. And what else did they give us? Measure of angle GAB. This one right here. GAB. What's the measure of GAB? 65. And the measure of angle HCB, what's that? 35. So since all this, that's all what we know, right? Here's what I'm going to do. My logic is this. I know all of these angles right here add up to 180, right? I'll have to prove that eventually. But if I can find out what this angle is and find out what this angle is, I can subtract those two from 180 and I get this guy for free, right? Are you seeing my logic? So if I can prove this angle is equal to something and this angle is equal to something, I can subtract them and find this guy. So my first job is going to be to do this. I want to find out what this orange angle is right there. Well, I'm going to use CCP to prove what that angle is. So this angle is angle GBA, right? That orange angle. So GBA, that's last, middle, first, right? So let's look over here. HCB. HCB is also last, middle, first. So by CCP, those angles must be the same. And if you look at them, they do look like they are, aren't they? So because they're in the same order, last, middle, first, and the triangles are congruent, I can use CCP to show that this and this are the same. So this is 35. So let's write that. Let's write angle GBA, the measure of it, is 35 degrees by CCP. Okay? Same logic here for the blue angle. What angle is it going to be congruent to? HBC. Well, HBC, that's not there. It's here. HBC. Last, first, middle. Is it congruent to GAB? Last, first, middle. Yes, it is, isn't it? So I know that measure of angle HBC, the blue angle, is going to be what? What's the measure of this angle going to be? $65. And how do I know that? CCP. Right, I know the triangles are congruent, so I had to ask myself, which angles are congruent? Well, these two angles are congruent. I checked the letters to make sure they matched up, right, and they did. And I know these two are congruent, because I checked the letters to make sure they matched up. So now I've got these two. How can I find this one? Well, I subtract them, right? So if I subtract that from 180, that's going to add up to 100. So that means this angle right here, the yellow, that's going to be 80. Now, how do I show that in proof form? I say this. Measure of angle GBA, that's this guy, the orange angle, right? Plus the measure of the yellow angle, GBH, plus the angle, the blue angle, HBC, should all add up to 180. You follow me? And how do I know they add up to 180? We're going to cheat a little bit. We're going to call linear pair theorem. Linear pair only works with two angles, but I'm going to say, look, they're all on a line. They all add up to 180. That saves you a step. Okay? So by linear pair theorem, they add up to 180. Then by substitution, which I'll abbreviate with subs, I can switch out measure of angle GBA for its measure. So instead of writing measure of angle GBA again, I'm going to write 35. 35 degrees? I don't know this one, right? So I can't plug in anything there. What's the measure of HBC? 65, so I'm going to plug that in. That's what substitution means, to plug in, right? So I've got that now. And then now we just do math, right? So therefore, the measure of angle GBH equals, when you subtract all those from 180, you get 80. And you're done. So let me break this down into steps. I'll do it in red. So step number 1 is to write what they gave you, right? That's step 1. Write what they give you. We always do that for every problem, right? Sense, blah, 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 blah. Step 2 was to use CCP to find out what these guys are. These two right here. That was step 2. Step 3 is to set up the equation and solve. So how do we set up the equation? We have to add all these together to equal 180, right? That's going to be our equation. How did we know that was okay to do? Linear pair theorem. Okay? So let me highlight in, let's use purple. These are my reasons why. Linear pair theorem, subs for that. CCP for these. Sense, they gave it to us. Okay? So we start out with sense, blah, 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 what they gave us. Then we showed that these two angles, we know what they are by CCP. Then we set up the equation that they all have to add up to 180 by linear pair theorem, because they're all in a line, right? And then we substitute their values by subs, and then we do math. How was that? Not easy. You might have to study a little bit, but like not impossible, right? Good, good. That's really good, Grace. And again, if you have any questions, Bailey would be an excellent person to talk to. She's really good at these proofs. I've been so proud of her this semester. I'm so proud of you, Bailey. All right. That's it. That's it. So, Grace, let's do a bonus round. This one's going to be for you to do on your own. Let's do this. So here's the figure I'm giving you. I'm telling you, this is A, B, C, D, E, F. I want you to prove that BE bisects that segment FD. Okay, so I want you to prove BE. Oh, you can't see. I want you to prove that BE cuts this part in half. And how are you going to do it? Well, I'm going to tell you this. This is what I'm giving you. Since rectangle ABEF is congruent to rectangle CBED. There's your start, okay? I gave you that these two rectangles are congruent, okay? Use that to prove that BE bisects FD. Try that now.
Drew, can you, Drew?
It's very similar to the first one we did on the review. Except we're not bisecting an angle, are we? We're bisecting a line segment. Still got to prove the same thing, though. Should take about 3 steps to do it. The last step will be to write what they wanted, right? So you'll write BE bisects FD. That'll be the last part. The middle part is what you've got to do. So Grace, did you have any luck? Any luck? Let me see what you got. Excellent. All right. So you knew that EF had to be congruent to ED. And how did you know it is really the question? That's all that we're missing here. So well, you knew the two rectangles are congruent, right? So how did you know these two are congruent? Check the letters. EF, ED, same order. So CCP is how you knew, okay? Last step, we write what they wanted, and we write by definition, because if that thing right there is cutting this in half, then it's a bisector, right? We just proved it cut it in half, so that fits the definition. That's it. Not bad. Nice job. One more bonus round. This one might be a tricky one if you don't remember your theorems, Grace, but I'll give it to you. We'll see. So I've got this line, and I've got 2 other lines that it is cutting. And I'm going to tell you that these lines are parallel. That's what that extra little arrow thing there means. All right. So I gave you that the lines are parallel, since L is parallel to M. Here's what I want you to prove. I want you to prove angle 3 is congruent to angle, let's do angle 5. So try that. We're going to run out of time, so I'm going to end the video now. Try that. Leave your answer in the comments. Provide your proof.